One of the problems that we've always had is to measure pain. Pain is a subjective response. And so it has multiple components. It has a sensory component, so we can sort of know, where the pain is. We can discriminate the location of the pain. It's in my finger, it's in my shoulder, whatever it is. But it also has other features that are a little bit different from other sensory responses. Pain has an affective component and a motivational component. So pain is a sensation, but unlike other sensations that are sort of affectively neutral, pain is unpleasant. Pain is always unpleasant. It's unpleasant at threshold. It's the unpleasantness of pain that produces motivation. So if we have pain, we have strong motivation to escape and to seek relief from that pain condition. And so the reason for describing that is that how do we measure pain? Well, measuring pain, even in humans, is difficult. The way that we measure pain in humans is we ask humans about their pain. We say, how much pain do you have? And we use rating scales, numerical rating scales, visual analog scales, something like that. And the humans tell us. Now, it's okay to do that. And we believe humans when they tell us that their pain is an 8 out of 10 or 7 out of 10 or 5 out of 10. But what we would prefer to do is we'd like to have an objective measure of pain. And so sort of like a blood test, what is your cholesterol level? We get a number. We don't have that in humans because pain, again, is fundamentally subjective. So now if you take that and you translate it to the preclinical laboratory and you say, how do we measure pain in a nonverbal animal? Well, that becomes particularly challenging because we can't ask the animal about their pain, and yet we'd like to know if our treatment produced relief of pain, like a migraine. And so one of the things that we have done is we focused on the motivational qualities of pain. Pain is aversive, it produces motivation to escape and to seek relief. And what we find is that if we have relief of an aversive state, then that is actually rewarding. And so the way that you can think about it is that if it's a very, very hot day, for example, and you jump in the swimming pool, well, that makes you feel better. So relief of an aversive state is rewarding, and it activates the classical mesolimbic dopaminergic reward pathway, and it produces motivation. And so that's what we've done. If we have ongoing pain, we produce relief of ongoing pain, that animals will seek a context. There is a learning paradigm where they can seek a context that's associated with relief of that aversive state. So that gives us insight into whether the pain is there, and secondly, whether the treatment that we've given is effective in producing relief of pain by removing the motivation on the part of the animal to seek a context that's associated with relief of an aversive state.